Priyanka, Sandhya,
Yes, sir.
okay. Santosh, Santosh Sonar, Shabaz,
Present, sir.
right. Shafia, Shafia, Sridhar,
Yes, sir.
okay. Srushti,
Present, sir.
right. Siddharth, Siddharth Patil, Supriya,
Present, sir.
Present, sir.
Siddharth is present. Varnekar, okay.
Yes, sir.
Siddharth Patil, Supriya,
Present, sir.
okay. Vandana, Vasant,
Present, sir. Sir, Vandana.
okay. Vasant, Vasant, Vedata, Vedata, Yogesh, Yogesh, Mahesh, Mahesh, Balesh, Balesh, Taik Mohammed,
Yes, sir.
right. Praveen Rathod, Praveen, Abhishek,
Yes, sir.
okay. Aishwarya,
Present, sir.
okay. Amanullah, Amanullah, Bandurkar Tanay Mohandas, Bandurkar Tanay Mohandas, Baurav, Baurav, Shodhan,
Present, sir.
okay. Devanar Anil Kumar Shekappa, Nand Kumar, Pramod Kesti, Rohini, Rohit, Shashidhar,
Yes, sir.
okay. Sridhar,
Present, sir.
right. Snehal, Vaishnavi, Saish, Karthikyam, okay. Anybody else? Anybody else? Right. Are you able to see the screen here?
Yes, sir.
Right. Next is logical operators. You are already familiar with these logical operators such as AND operator, OR operator, XOR operator, and NOT operator. Right? You have already studied these gates: logical AND gate, OR gate, XOR gate, NOT gate. Okay, the same operation that we are performing using these operators. For the AND operator, this AND symbol is used. This AND symbol. For logical OR operation, this vertical line is used. And for XOR operation, this vertical inverted V is used. Inverter operation, this congruent operation is used. Symbol is used. These are the various symbols used for the logical operators. Okay. Now let us take one example for each and let us try to know how these work. First one is AND operator. AND operator. If A value, if A equal to 0 and B equal to 0. If A is 0, B is 0, then A and B. A and B. This is 0 and 0. A is 0, B is 0, 0 and 0. So the AND of A and B, that will be 0. Am I right? Then next, let us consider A as 0 and B as 1. B as 1. The logical OR operator. The logical OR operator of A or with B. A is OR operator or with B 0 plus 1. 0 or 1 is 1. Is OR operator, logical OR operator. Then next example for the XOR gate, let us consider A as 1 and B as 0, B as 0, A as 1 and B as 0. Then the operation of XOR on A and B, A XOR B, A XOR B, that is 1 XOR 0 is how much? 1. 1 XOR 0 is 1. The next one, not operation or the inverter operation, not operation. Let us consider inversion of B, value in B. If we consider not of B, y is equal to not of B, that is not of B. If we consider the not operation, then this will give us not of 0 is 1. If we consider not of 1, it is 0. If we perform not of 0, it is 1. Okay. So this is how various logical operators are used to perform the operation. This is AND operation, OR operation, XOR operation, and the NOT operation or the inversion operation. Right. Now, what are the applications of these logical operators? These logical operators are used in applications of embedded systems, in microcontrollers, and in microprocessor based systems. These are various applications of the logical operators that are available in the C language. These are the logical operators available in C language. Logical AND, logical OR, logical XOR, and logical NOT, or the inverter operators. Here we have to understand how these work. For example, if I give some values, you will calculate and tell me what is the value after performing this 0x35, 0x35, and with 0x0f, 0x0f. Tell me how much you will get. 0x35 is how you will write 0x35. P5. Okay, it is 0, 0, 1, 1. Then 5 is 0, 1, 0, 1. Next 0x0f, that is it is 0f. 0 is 0, 0, 0, 0. Then f is 1, 1, 1, 1. Perform logical AND of these two values. Tell me how much you are getting. What is the answer here? How much you are getting?
0, 5.
0, 5. Let us see. So this 0 and 0 is 0, and starting from this end, it's a logical AND operation. 0 and 0 is 0, 1 and 0 is 0. This is 0. Right? 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1. So this will be 0, 5. 0, 5. You are getting correct. 0, 5 hex. Okay. Let us take one more example of logical OR gate. Logical OR. 0x04, 0x04, or with 0x68, 0x68. You all tell me, calculate and tell me how much you will get. 0x04, it is 04, 0000, 4 is 0100, right? 68, 0x68, it is 68. 68 is 01106, then 8 is 1000. Tell me the answer, students.
0.
Answer is 0. Let us see how it will be 0. Let us check. So 0 and 0, let us start from the LSP. It is not correct to start from MSP. 0 or 0 is 0. Then 0 or 0 is 0. Then next, Here 1 or 0. 1 plus 0 is 1. 1 plus 0 is 1. Okay. 0 plus 1 is 1. There is 0 or 1 is 1. Then next 0 or 0 is 0. 0 or 0 is 0. Then 0 or 1 is 1. Okay. 0 or 1 is 1. And last one 0 or 0 is 0. How much we are getting? 0 1 1 0 1 1 0 0. How you all calculated? You are getting 0 there. Just check. This is how you have to perform.
I think it's
Clear?
I think it is
Huh?
and sir. And
You thought it
sir,
as
logical and
OR operation. This vertical line is for OR operation. This ampersand symbol is for AND operation. Remember, this ampersand symbol and symbol is for logical AND gate, logical AND operation. This vertical line is for logical OR operation. Okay, accordingly you have to calculate. Okay, that's why you have to read the question first. Okay, otherwise if we are not reading the question, we are writing the answers, means we will go wrong, right? So always read the question, try to understand it, what is asked, and then write the answers. Next, we'll perform XOR operation. 0x54, 0x54, perform XOR with 0x78, 0x78. Do this and tell me how much you'll get. Tell me the answer here. You'll have to perform this. 0x54, write 54 first in binary, then write 78 in binary, and perform the XOR operation bit by bit.
So can you pardon the question?
0x54 XOR with 0x78. This is written here. 0x54 XOR with 0x78. You have to calculate the answer. You have to find out the answer of this. 54 XOR with 78. How much you all are getting? 54 XOR with 78.
2C.
2C, exactly, 2C. See how we'll get this. So this is 5 is 0 1 0 1, then 4 is 0 1 0 0, then 7 is 78 0 triple 1, 8 is 1 triple 0. Write the bits. 0 XOR 0 is 0, then 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0. Then next, 0 XOR 1 is 1, 1 XOR 1 is 0. Sorry. Then 0 XOR 0 is 0. So 8 4 2 1 2C it is. Okay, 2C. 0 0 1 0 is 2. Then 1 1 0 0. It is 12. 12 is C. It is 2C. Okay. Last one, we will perform the NOT operation. NOT. Fifth example, perform the NOT operation of 0x55, 0x55, and tell me the answer. If you perform NOT of 55, how much you will get? Invert the bits.
A.
AA hex. Correct. 55 is 01, 01. 5 is 01, 01. Then perform inversion, invert each of the bits 1, 0, 1, 0. Then this 0 will become 1, 0, 1, 0. This will be AA hex, AA hex. Correct? Perform the NOT operation, invert each of the bits. Fine. So this is how these operators work here: logical AND, logical XOR, logical OR, and logical NOT. Clear here? So these examples are clear here to everyone. Any doubts in these examples?
Yes, sir.
Clear? Okay, fine. Let us move on to the next topic. Let us write programs on these logical operators. This program, write an 8051C program to toggle all the bits of P0 and P2 continuously with a 250 millisecond delay. Use the inverting operator. Write an 8051C program to toggle all the bits of P0 and P2 continuously with a 250 millisecond delay. Use the inverting operator. Okay, let us write. Read the question here. If we have to write 8051C program, there is one thing. We have to toggle the bits of P0 and P2, that is 55 to AA or AA to 55, correct? With continuously delay of 250 millisecond delay loop should be there. There should be delay function. Then we have to make use of inverting operators. There are four things here. First thing is write a 8051C program. Second one, toggle the bits of P0 and P2. Third one, use the delay of 250 millisecond. Then fourth one, use the inverting operator. Understand the question and then start writing the program. Hash include reg51.h, reg51.h. Then delay function, we'll write the delay function void ms delay of unsigned integer value. We are passing from the main function to the sub function, main function to the sub function. Therefore, we have to write it as unsigned int. Then main function void main. We are not passing any value, so make it empty. Then the delay is then main function is there. Then next is we have to use the values for the ports. P0 is equal to 0x55, 0x55. Then because the other port they have mentioned P2. P2 is equal to 0x55, 0x55. Right? Then we have to introduce a delay. Okay, we have to introduce a delay. Before introducing a delay, we have to toggle it while of one, repeat for indefinite number of times. Now, how to use the inverter operator here? Okay, so I'll write it as P0 is equal to not of P0. P0 is equal to not of P0, not of P0, not of P0. Then P2 is equal to not of P2, not of P2, not of P2. Now what will happen here? Just see. P naught is equal to naught of P naught. What is there in P naught? Just now we saw inverting. If we perform inversion of 55, if we invert, if we use not gate, not operation on 55, how much we are getting? How much we are getting?
AA.
AA.
Yeah, yeah.
Correct. So we are toggling. What is 55 here? 55 01 01 01 01. What is AA? AA is 1010 then 1010. So what is this? This is nothing but toggling. 0 to 1, 1 to 0, 0 to 1, 1 to 0. It is toggling. Correct. P naught is equal to naught of P naught. That means first it is 55. Naught of 55 will be AA. Then P2 also same. 55 will be toggled and it will become AA. Then we will call the delay function. Then we will call the delay function. MS delay, MS delay will pass the delay value. How much they have mentioned in the program? 250 milliseconds. Pass the value 250. Then end the while loop and end the main function. Now we'll write the delay function. We'll write the delay function. Void ms delay ms delay ms delay of unsigned int I time. Then next define the loop indices unsigned integer I comma j. Then define the write the true for loops for I is equal to 0, I less than I time, I less than I time, I plus plus. Next for j is equal to 0, j less than 1275, right? J less than 1275, because this is generating a delay of 1 millisecond. 1 millisecond into 250 is 50. Yes. Here, any problem?
ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾಗ ಸೇಮ್ ಇರುತ್ತಲ್ಲ ಸರ್ ಜೆ ವ್ಯಾಲ್ಯೂ
ಬರಂಗಿಲ್ರಿ, ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಕೊಡಕ್ ಬರಂಗಿಲ್ಲ. ಯಾಕಂತಂದ್ರ ಇದನ್ನ ಏನ್ ಮಾಡ್ಯಾರಿ ಅಂತಂದ್ರ ಟೆಸ್ಟ್ ಮಾಡ್ಯಾರ ಇದನ್ನ. Whatever this for loop is there, they have tested this by connecting to a oscilloscope. They have connected it to a CRO and the output of the computer, they have interfaced with the CRO, they have connected and they have monitored, they have observed the value of the delay that is being generated by these two for loops. That is this for loop for j is equal to 0, j less than 1275, j plus plus. So when this for loop is executing, it is generating a delay of 1 millisecond. It's a practical observation. It's a practical observation that when this for loop executes for j is equal to 0, j less than 1275 times, j plus plus is generating a delay of 1 millisecond. Therefore, based on how much delay we want, if you want a delay of 300, pass 300. Then use these two for loops. If you want a delay of 500, pass 500 from the main function to the sub function. Then use these two for loops. That will give us the required delay. Clear here, Nandish? Nandish?
ಎಸ್ ಸರ್
Okay. If you use some other values, it is going to generate some other delay. It will
Yes,
not
sir.
give us the delay of 1 millisecond. Okay. For j is equal to 0, j less than 1275, j plus
Yes,
plus,
sir.
then end the delay function. Okay. Fine. So this program will invert the bits of P0 and P2. That means it is going to toggle. So these are the various ways to toggle. Right. First thing that we saw in toggling is first what we did. Well, in the previous class, we wrote P0 is equal to 55, P2 is equal to 55. Then we gave the delay. Then we wrote P0 is equal to AA and P2 is equal to AA. Then we wrote the delay. This is one way. Another way of toggling is using the NOT gate, using the NOT operation, inverting symbol. If we use that, then also the bits will be toggled. This is how it is done. P0 is equal to not of P naught. First time it will be 55 will become AA. Then next time P naught is equal to not of P naught, AA will become 55. If we are toggling 55, first time it will be storing in P naught AA, right? So as it is AA, when it completes the delay and when it comes back, AA will toggle to 55 again. AA will toggle to 55. If we see and check what will be the not of AA, what will be the not of AA? Not of AA will get nothing but 55 only. Getting the point here? Therefore, this will continue and the not toggling will continue indefinitely because of the loop while of 1. Clear here? This is how we are writing a program for toggling the bits of the ports continuously with the delay, with some delay, right? Using the inverting operator, right? Is this program clear here, students? This program is understood? Yes. Is this program clear here?
Yes, sir. Understood.
Understood this program? Any questions here? Okay, right. We'll continue the next topic. Next is bitwise shift operators in C language. Bitwise shift operators. Okay, we have seen the shift operation in assembly language: right shift, left shift, shift right through carry, shift left through carry, right? RL instruction, RLA, RRA, rotate right content of A register, then RLA, rotate left right, sorry, rotate left the content of A register through the carry, RLCA, then RRCA, rotate right the content of accumulator through the carry. Okay, so these are the rotate instructions that we have seen. Shifting is nothing but the rotation operation only, but here that is slightly different from the rotation operation. We'll see what is shifting operation. Shift right. Okay, shift right is nothing but shifting, but when we are rotating, we rotate the MSB to the LSB, or we rotate LSB to the MSB. Here it is not like that. We just go on shifting the bits from one end to another end. Okay, we'll see how the shifting takes place. First one is shift right. Shift right is indicated by two these arrow symbols. Arrowhead is pointing to the right side. This is shift right. If the arrowhead points to the left side, then it is shift left. The arrowhead points to the left side, it is shift left. We'll see what is right shift first. The format of right shift is data, number of bits to be shifted right, number of bits to be shifted right, Next, shift left, that is data, then arrow mark. Sorry, this first one is left shift, it is shifted left, right? It is left shift. First one is the left shift, number of bits to be shifted left here. Arrowhead is pointing to the left side, left. Then right shift is data, these two arrows pointing to the right side. Arrowhead is pointing to the right side. Number of bits to be shifted right, right. Okay. Now let us take examples here. First example, 0x 9a, 0x 9a, right shift three times. Okay, so this is shifting right three times. Okay, now how to shift three times? Is 9a. 9a is 1001, then 3 is 0001. 1 1. This is 9A. Okay. Then, now if you want to shift it right 3 times, how we have to do it? We have to insert zeros from the left end towards the right side. Now if I insert 1 0 here, it is shifting. It is 1 0 0 1. Then we have 0 0 1 1. So this one I have shifted right. Yes, please. This one I have shifted right by 1 bit. We are inserting. Yes.
Sir,
ತಿಳಿವಲ್ತು? ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ?
sir, 1 1 1
Sir,
0
A ಅಂದ್ರೆ 110.
One ನಿಮಿಷ ರೀ. Sorry, correct. Right. Yes, I'm sorry. 1010, right? You are right. 1010, correct. It is 101. Thank you. 1010. Okay.
A value.
Correct.
A
ಇದು
value.
9 ಇದು ಕರೆಕ್ಟ್ ಐತಲ್ರಿ? ಇದು 849 ಕರೆಕ್ಟ್ ಆತ್ರಿ ಈಗ? ಕರೆಕ್ಟ್ ಆತಿಲ್ರಿ? ಇದು 9 ರೀ. ಇಲ್ಲಿ ಒಂದ್ ಸತಿ ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಇದು ರೈಟ್ ಶಿಫ್ಟ್ ಬೈ ಒಂದ್ ಸತಿ ಆಕೈತ್ರಿ ಇದು. 0 ಇನ್ಸರ್ಟ್ ಮಾಡಿದ್ರಿ ಈ ಕಡೆ. ಲೆಫ್ಟ್ ಸೈಡ್ ಇಂದ ನಾವು 0 ಇನ್ಸರ್ಟ್ ಮಾಡಿದ್ರೆ it is towards the right side. It goes on shifting. Okay, it is shift by 1 bit. Next, if I insert 2 zeros, it is right shift by 2 bits. It is 1 0 1 0. Okay. Next, if I insert 3 zeros, then it is right shifting by 3 bits. 1 0 0 1 1 0 1 0. Okay. Now we have to see 8 bits from left towards right. We should not leave these zeros. How many? Yes. Here, Nandish. Mantesh. Mole Prem. कैसा है मोले? Mantesh कैसा है?
हाँ सर कैसा है?
कैसा है? Okay, right. See, we are inserting 3 times right shift. 1 निमिष. We are inserting 3 times zeros. Okay, we are inserting 3 times zeros right side. ಏನಾತ್ರಿ ನಂದೀಶ್ any problem? Mole Prem?
ಸರ್ ಅದು 1 ಆಗ್ತದ ಸರ್ 3 ಬಿಟ್ಸ್
ಯಾವ್ದ್ರಿ? ಈ ಕಡೆ ಇದೆ. ಇದು 9 ಇದೆ. ಇದು ಸೇಮ್ ಐತಿ
ಸರ್ ಅದು 3 ಬಿಟ್ಸ್ ಶಿಫ್ಟ್ ಮಾಡಬೇಕಲ್ಲ ಸರ್.
ಶಿಫ್ಟ್ ಅಂದ್ರೆ ಏನಾಕೈತ್ರಿ ಇಲ್ಲಿ? ಶಿಫ್ಟ್ ಮೀನ್ಸ್ zeros are inserted from left side towards the right side. Zeros are inserted from left side towards the right side. That is called a shifting here in microcontroller. Okay, in C language shifting.
I think that
ತಿಳಿಲಿಲ್ರಿ ಇಲ್ಲಿ ನೋಡ್ರಿ. ಇದು ಫಸ್ಟ್ ಟೈಮ್ 0 ಇನ್ಸರ್ಟ್ ಮಾಡಾತೀವ್ರಿ ಇಲ್ಲಿ. I will highlight it, then you will understand. This is first time we are shifting. Okay, this is first shift. 0 we have inserted. Then we are inserting one more 0. It will become 2 zeros. Okay, that is shift right side by 2 times. Okay, then we are inserting 3 zeros. It is shift right by 3 times. Okay, so after shifting right by 3 times, we have 8 bits. We have to count the 8 bits from left towards the right. So this is 4. Okay, so this is the data now what we require. Okay, this is the data. So what is this? 0001 0011. Okay, leave these 3 bits because they are beyond 8 bits. A register can contain only 8 bits. So these bits will be truncated. These 3 bits will be left off. Okay, because it will not fit in the 8 bit. Register is maximum 8 bits. When we are shifting zeros from left towards right, it will fit only these bits, 8 bits. So what is the value then? 0001. 0001 is 1. 0001 is 1. Then 0011. 0011 is 3. So it is 13 hex. 13 hex. Did you all understand now concept of right shifting? Is it clear, Nandish? 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 Mantesh?
Yes, sir. Clear, sir.
Clear atalri? Okay, fine. Similarly, we'll take for the one example for the left shift. Left shift. One more example we'll take for the left shift. So now by this time
Yes,
you
sir.
understood the meaning. By this time you understood the meaning of shifting. Okay, you understood the meaning of shifting. Shifting means inserting the bits. Inserting the bits. Okay. So next 0x6. This is slightly different. You'll see this 0x6 shift left by 4 times. This is shift left 4 times. 4 times. Shift left 4 times. Now shift left 4 times. This is 0x6. Now how do you write 0x6? 6 means there is no 0 here. Remember, it is only single digit 6. So you have to write only 0110. 0110. It is 6. Only 6 is there. Okay. If you see this one 9a, we wrote 9, then we wrote a. If nothing is there here, don't write anything. It is not 0. Remember this. So such examples, if they ask an examination, we have to do it. We have to think a while and we have to do it. Okay, so 0x6, if nothing is there, it is not 0, it is 6, only 6. Then we have to insert 4 zeros from right towards the left. You have to insert 4 zeros. So if we insert 1 0, it will become this. Right? Then what I'm doing, next time I'm inserting 2 zeros. 0 1 1 0 0 0. I inserted 2 zeros. Then next, I will insert 3 zeros. 0 1 1 0 0 0 0. Then next, I'll insert 4 zeros. I'll insert 4 zeros. 0 1 1 0 0 0 0 0. Now check what is the final value. I'll highlight them so that you will understand. This is 1 0. This is 1 0 here. Then this is 2 zeros we have inserted from right side towards the left is left shift. Then 3 zeros we are inserting from right side towards the left. Okay, it is 3 times left shift. Then 4 zeros we have inserted from right side towards the left. It is shift left 4 times. Now at the end, this is 8-bit data. This is 8-bit data, whatever we are having. So it is fitting into the register. It is fitting into the register. So the value of this will be 0110. 0110 is 6. Then 0000. 0000. 4 bits. It is 0. So the finally we will get 60 hex. 60 hex. Right? So this is how we are supposed to find out the value after left shift what will happen and after right shift what will happen. Okay, you all understood here? Okay, you can try out this example for homework. Just try out this 0x77 0x77. Then it is right shift 4 times. Right shift 4 times. Okay, you all do this and tell me the answer in the next class. 0x77 right shift 4 times. Okay, you all understood here, students, what we discussed in today's class? Was it understood? What all we discussed in today's class? We started with logical operators and or XOR and inverter. We discussed few examples on these operators. Then we discussed a program to toggle bits of P0 and P2 continuously with 250 millisecond delay using inverting operator. Then we discussed bitwise shift operators in C language. Shift left and shift right and shift left. Okay.
Answer is
Any
07.
questions? Inatri?
Answer 078.
Correct, Aitri Nandish. You are right. Others, you will try to solve it and tell me the answer in the next class. Okay. Fine. Any questions here? Everyone understood, I suppose? I suppose everyone understood here?
Yes, sir, understood.
Fine. Okay. Then we'll continue in the next class with the programs on these shift operators. That will take up in the next class. Right. Thank you.
Yes, sir.
Okay.